Okay, welcome back, Math 10s. We're going to dive into 3.2. I know the first lesson is a long one. I break that into two smaller lessons in class, but do take breaks going through that 27-minute lesson on YouTube if you are watching it for the first time, I hope. But I guess you are now ready for 3.2 no matter how you did it. So let's remember our acronym, SOHCAHTOA. It looks like this. We kind of write it in a funny way because it helps us remember our ratios or fractions. So SOHCAHTOA. And just remember that this stands for the sine is equal to the opposite divided by the hypotenuse. The cosine of an angle is equal to the adjacent divided by the hypotenuse. And the tangent of an angle is equal to the opposite divided by the adjacent sides. So we have angles using the trig functions to find the ratios of the sides. Now, we can use this to find missing sides. All right, so let's see how to use this. Find the length of the indicated sides to the nearest tenth, or one decimal place. Okay, so we want to find side BC. So let's look at this triangle. There's my 90-degree angle. Side BC is right here. So I'm going to call that BC with a line over top. Okay, so that's just another way to name it. We could call it X is fine too, but we're just going to be calling this side BC. Okay, now we got to figure out which ratio am I going to use right now. I know this angle, but I don't know the other one. Okay, so I know this 50-degree angle, and I know only one side. I know this is actually technically the hypotenuse. It's opposite the 90-degree angle. So let's name our other two sides. Okay, our other two sides in reference to the angle we know, the 50-degree angle. So this is going to be our opposite side, and this BC is also going to be our adjacent side. So now we want to think, which ratio am I going to use? Well, I have three choices. If I used sine, I would know the angle is 50. I know the hypotenuse, but I don't actually care about the opposite side in this question. It's not asking for side AB. So that tells me that I can actually ignore sine and tangent because I'm not concerned with the opposite side, AB. I only care about what the question's asking me. So let's just answer that. Let's find side BC here. So we're going to be using cosine. Now, the reason we use cosine is because in reference to the 50-degree angle, we know the hypotenuse and we need to find the adjacent side. So this adjacent side we're going to call BC, and we do know the hypotenuse is 5.2. Okay, now we just got to do a tiny bit of algebra. I'm solving for BC, my unknown side. So how could I do that? If you remember, I need to get rid of this division by 5.2. And to get rid of division, we multiply both sides by 5.2. So that's exactly what we're going to do. We're going to multiply both sides by 5.2 to get BC by itself, because now I've canceled this out. 5.2 and 5.2 cancel to 1. And so on this side, I'm left with side BC. And over here now in our calculator, I can go 5.2 and multiply it by the cosine of 50 degrees, okay, which is going to give me a result of, rounding to one decimal place, 3.3. And in this case, we do have units, so centimeters. Okay, that's all we have to do. So we set up our triangle, we label it based on what we know, and we determine the side that it's asking for using the correct trig function, which in this case was cosine. Now, to show how this looks in a calculator, just to review, I'll bring up my Desmos calculator again. I think I have it open here. Yes, so let's clear what I have. And so I take 5.2 and then I'm multiplying that by the cosine of 50 degrees. And you see here, I do get 3.34 and many other decimals, but if I rounded it, I get 3.3. Okay. Again, I'll help you with your calculators in class. All right. How about side AB? We got a new triangle over here. This is side AB is right here. We do know, again, this side, so we're labeling things the same way. Again, this is our hypotenuse here. Here's our opposite side from that reference angle, and here's the adjacent. So this time, using SOHCAHTOA, which ratio am I going to use? Well, again, now I don't know the adjacent side. I don't care about the adjacent side. It's not being asked for. So I do know the hypotenuse, and I want to find the opposite. So we're going to use SOH, or SOH. We're going to use the sine of the angle we know, which is 50 degrees, and that is going to be equal to the opposite over the adjacent. Well, the opposite is side AB. That's our unknown. We don't know what it is yet, and we do know the hypotenuse is 5.2. And we're going to do the exact same thing here. We need to isolate what we're trying to solve for. So I'm going to multiply both sides by 5.2 again, because remember that the sine of 50 degrees is just some decimal. Okay, it is a number, and that's really easy. So now we can see this cancels. I'm going to be left on the right side with what I'm trying to determine, the length of AB. And when I put this in our calculators, we are actually going to get approximately 3.98 and a bunch of decimals. And we're going to round that, of course. So side AB is equal to we need to round to the 10th. Let's erase that before I forget. We have to round to the nearest 10th. Well, this 8 tells me to round up the 9, which rounds it up to 10. So we're going to actually round this all the way up to 4.0 centimeters. All right, moving on. Let's find the length of the sides here to the nearest 10th. So now we have a new triangle. Here's our reference angle of 55 degrees. So let's label everything first. The opposite is over here. So this is my opposite side. The adjacent is right beside it. And the one opposite, the 90, is always going to be my hypotenuse. Okay, so I've named my triangle, and it's looking for side EF. So EF looks like it is right here. This is the side I want to know. I want to find the adjacent side to that angle. So I don't know the hypotenuse. So just remember, if I look at SOHCAHTOA, in this case, hypotenuse, we don't know it. We're not trying to find it. So the two trig functions, sine and cosine, both use the hypotenuse. I'm not going to be using those in this question. I'm going to use TOA. I need to use tangent. So let's set this up. The tangent of the angle of 55 degrees is equal to the opposite over the adjacent over A. So we do know O this time. It is 6.8. And I'm trying to find side EF. Okay, now this one's a little bit different. I have 6.8 and I'm dividing by the side I'm trying to figure out. But we use the exact same strategy. I need to isolate this, but to do that, I need to get rid of this 6.8. Now, because we're dividing by the unknown, by the EF, we're going to need to get that up on top. We cannot solve for a variable or a missing side when it is in the bottom of a fraction. So we have to do a little bit of manipulation here using algebra. I'm going to multiply both sides this time by EF. Okay. All right. We won't be done. This is going to require one extra step. So now the EFs are gone. I no longer have my unknown side in the bottom of a fraction. So over here now I have EF times the tan of 55 degrees is equal to 6.8. Now, what do I need to do next? Well, if we remember algebra, I have EF times the tan of 55, remember that's just a number, is equal to 6.8. Well, I need to get rid of this tangent of 55. I want EF all by itself. I'm trying to find the side length. And to do that, we just have to do the opposite of multiplication. The opposite of multiplying by the tan of 55 degrees is dividing by it. So we're going to divide both sides by the tangent of 55. Okay? And again, so this is now going to cancel. That divided by that is 1. So I'm going to be left with EF And when you put this in your calculator, 6.8, and divide it by the tangent of 55, again, make sure you're in degree mode, you are going to get 4.8 centimeters when you round it to the nearest tenth. Now, whenever you have the unknown here, you might notice something that has happened. There's been a bit of a swap. So if you want to do this faster, so I'm going to say or, I'm going to put an or over here. Here's another way of doing it. Let's maybe switch to, let's go back to red. Okay, we are just swapping. So our original question in red here, the tan of 55 and EF just switched. So we can see here that EF was equal to 6.8 divided by the tangent of 55. So we can easily set that up by just doing the swap. Okay, so which looks like this. If I take the tangent of 55 degrees is equal to 6.8 over the side EF. If our unknown is in the bottom, we can easily just do a swap. That's all that's happened. So these two things have swapped. We see that over here with our algebra. So if you can remember that, you can create yourself a nice little shortcut to determine that, oh, this is the same as EF is equal to 6.8 divided by the tangent of 55, which will give you the exact same answer rounded to 4.8 centimeters. Okay, so that's a nice shortcut to save you those two algebraic steps. So let's do one more and we're going to be done this set of notes. We're going to find side DE. So we look over at our triangle here. We're actually going to be determining the hypotenuse this time. DE is this side, okay? And in reference to this angle, again, our labeling is going to be the opposite side is over here. So here's our opposite. The adjacent is here and our hypotenuse is the side we're looking for. So again, for SOHCAHTOA, which ratio should I be using? We can simply look at what do we know or what do we not need to reference. Well, we have 55 degrees here, and I do know the opposite. Okay, so that tells me I'm going to be using sine or tangent, and the side that I want to find is the hypotenuse. Well, tangent does not utilize the hypotenuse. We're going to be using sine this time. So we're going to be taking the sine of 55 degrees, which is then equal to the opposite, which we do know is 6.8, and we're dividing that by the hypotenuse, which is what we're trying to determine. Well, let's use our shortcut because we just figured that out, that when I want to solve for this, instead of doing those two slightly extensive algebraic steps, we can swap these two. And so we know that our side DE is going to be equal to 6.8 divided by the sine of 55. So we're going to put that in our calculators, and it's going to tell us when we round it to the nearest tenth is that it's 8.3 centimeters. Okay, and that concludes this lesson. We'll see you in 3.3. Have a good one.